Hi everyone, welcome back to my channel. I'm Coding Cosmo, and in today's video we're going to continue talking about types in the C language. In the last video of the series we have talked about the scalar types such as int, char, etc., which are mainly used to represent numbers, and we've also seen how these types were encoded in memory as bytes. Today we're going to learn about more complex types that the C language offers in order to represent more complex and structured data than just numbers. We're going to start right away by talking about arrays, and you can see that I'm using the same misc.h files that you can find in the link in the description of this video, which will just contain routines for us to see behind the scene how information is encoded in memory. An array in C is a finite collection of elements of the same type. So let's say I want an array of int. I'm going to say int, my array. Let's say I want 5 of them, and I'm going to ask for 1, 2, 3, 4, 5. If I want to access element of the array, it's the same syntax as in Python. So I'm going to ask for, the first one will be at index 0, and the last one will be at index 4. And if we compile this, we have 1 and 5. Now, arrays are mutable, so I can come and say that I want my array 0 to be equal to 345 and my array 4 to be equal to -4. And now, when we print these values, we're going to see what we expect. However, arrays are static in length. It means that you will never be able to add more than 5 elements to this array. Once you've declared that it has 5 elements, it's final and you cannot change this. However, the compiler is a bit smart, so you can you don't really have to put this 5 because the compiler will understand from the definition that you're using 5 elements. However, if you want to define this array but use it later, you will have to give a size and then say, okay, my array 0 equals 3, etc. Okay, so now how are they represented in memory? So to answer this question, first we're going to see what's the output of size of. So how many bytes this array represents? The answer is 20. So that's interesting because on my computer, an int is 4 bytes and I have 5 of them. So 5 times 4 is 20. If I add an element, we're going to see this value increase. So the size in bytes of an array is just the sum of the size of all the elements. And if we look in memory how this information is encoded, we do show bits of my array. I will put only 3 elements not to flood our screen. What we're going to see is our 3 ints, so 3 sets of 4 bytes, 1, 2, 3, which are just put contiguously in memory. So we can see here the function replies, shows things in the inverse order. We see first 3, then 2, then 1. We can omit this, it's just a detail of how the showBit function was constructed, but we see that in memory, the array just consists in putting the values next to each other. Now, one thing is that from C99, actually, the size of an array can be a variable. What does it mean? It means that it's completely legal to say array size equals 5, and then my array size. To define your array like that, you can use a variable to define the size. Now, if we want to be really precise, generally the type that is used to represent the size of an object in C is called size underscore t. And the right header that we need is std_def. So size t will be used for indices of arrays and for the size of an array or of any object in general. For instance, the function sizeOf in C, it returns a type size t because size t represents the size of something. It's even possible in after C99 to ask this value at runtime. So again, we're not going to talk too much about this syntax, but it's just to show you that if you ask, so the specifier for size t variables is zu. If we ask for the value of array size to our user, it's going to work. So here I can send 12 and an array of size 12 is created. It's not something that is really recommended in practice for reasons that we'll explore in the next videos that will talk about memory in more details, but basically nothing prevents you, at least, from giving the size of your array as a variable. Okay, now we're going to talk about strings. So strings are in C literally an array of char, which makes sense. So we say char, for instance, str, and here we use double quotes for saying hello. The way to print a string, the specifier will be %s. Here, if we compile this program, we're going to see hello on our screen. Now, by curiosity, we could say, okay, what's the size in terms of bytes of our string? So let's go for that, size of str. And for some reason it answers 6. Whether here we can see we have 1, 2, 3, 4, 5 characters. So that seems odd because we know that a char it's 1 byte. So from what we're seeing on the screen, it should be 5, and we see 6. That's the reason why is because when we write this, so what the compiler is going to do, compiler transforms to char str equals, and now an array of chars, so we have the H, we have the E, we have the L, we have the L, we have the O, and it will add a special character to signify the end of the string, which is \0. So one thing that could be confusing from Python is that in C, single quotes and double quotes, they do not mean the same. Double quotes are used for string literals, whereas single quotes is for char literals. So those two strings are exactly the same object. If you want, this is kind of syntactic sugar for giving that. And now we understand why size of and answer 6. It's because we have this character, special character at the end. Having this special character actually is quite nice because it allows us to have simpler manipulation on strings. So let me give you an example. For instance, let's say we want to make a function that computes the size of a string. So here we're going to call that str2. There is a function to do this. It's given by the standard library in the header string.h. And here, if we ask strlen of str, it's going to answer 5, because we have 5 characters. And because I told you that those two things were exactly the same as far as the compiler is concerned, we're also going to see 5 here. But what if we wanted to write our own strlen function? So here's the first function we're going to write in this series, but you're going to see it's pretty much the same as in Python. We start with a return type, which is going to be size t, and we're going to call that my strlen, and what it takes in parameter is a string. And thanks to this behavior of C, which is that each string is finished by this character, what we can do is we declare an index, I, which will start at 0, and while stri is not the special character, we're going to do I plus equals 1, and then we return I. And from that, we can see that my strlen of str is equal to 5. So, long story short, having this special character is very helpful when you do manipulation of strings, because you'll always have an information of where the string is ending. There is in C a very tight and unfortunately sometimes confusing relationship between the concept of array and another concept, which is maybe the most dreaded concept of the C language, which is the concept of pointers. When we deal with strings, which are array of chars, it's usually much more common not to see this syntax, but to see this syntax, which I will not explain for now, but you'll see that it compiles and we'll get the same thing. However, the concept that is here is called a pointer and is strictly different than the concept of array. However, there is a relationship between those two concepts that we will cover in future videos. And this is true for an array of char, for an array of int, for an array of any type. Another point is that we've seen how to compute the length of a string using the strlen function, which makes use of the special character here. But in general, how would you compute the length of an array? In C, there is no special directive like len in Python that lets you get the length of any list, which means that there is no direct way, if I define an array, to get the length of this array. From what we've said, we can do the following arithmetic. And indeed, if we compile this will answer 5, which is the length of our array. However, the tricky thing, which is related to this relationship between array and pointers, is that as soon as you will give an array to a function, this relationship here will not work anymore. And in fact, the compiler gives us a big warning that we are not going to explore today. But basically, you see that first we get 5, which is the size of our array. We have 5 elements, but then we get 2. Whereas we've not changed the content of our array before we've called this function. This is related to the relationship between arrays and pointers, and we will not cover this today. So it means that in C there are no canonical ways to get the length of an array, and if it's an information that you need in your program, you will have to save it in a variable and transmit it to the function that would need to know the length of an array. From that, we understand the trick that is used in strings, because thanks to the special \0 character, the problem of knowing the length of the string is simple, whereas there is no such trick for arrays in general. Now we're going to talk about the concept of structs in C. Structs are like classes in Python, but with no methods. It's just storing data or attributes. So for instance, let's say we're working on making an RPG game, and we have a struct. We want to define what are the attributes of a player. So we have maybe its health count. We have maybe its strength. And because it's a game that will be played in the terminal, we have characters that will represent the avatar of the player. And now, if I want to create my player, the syntax is as follows: struct player, my player, and here I can say that my health is 12, and let's say my strength is 10, and my avatar is the arroba symbol. And now, for instance, I can print my avatar by doing my player dot avatar. We can see that the program has printed the avatar of the player. Now, this syntax often looks a bit cumbersome when we come from another language, because we're like, why do we use the keyword struct to define the variable when we expect to use the keyword only to define the type? That's because in C, you can think of it like that, is that the type is called struct player. So it's like if the type was called int or char or whatever. Now here the type is called struct player, and here we've defined the type called struct player. But in practice it's a bit cumbersome to have to write struct player each time. So we can use the directive typedef, which will just alias a type. You can use it to alias any type. And here we're going to alias the type struct player. We're going to rename it as player. So here we just have to write player. And everything works. There is also another syntactic sugar, is that you can do this all at once in the beginning. You can write typedef struct and call it player. So this syntax will do everything at the same time, and here we can see it compiles and everything's fine. Okay, so now a legitimate question is, how is the information of this struct represented in memory? So To answer that question, we can ask. So we're going to show the bits, which again is a directive which is in this file misc.h, which is going to show the bit of my player. Okay, so a lot of information that we're going to try to decipher, but basically, remember that my function, for some reason, it prints everything backwards. So the first information that we're expecting to see is the car of the avatar. Here, the first non-zero byte that we read is this. So, and yes, so we see that it's 0, 1 followed by 6 zeros as we're reading here. So that's our base. And here, now, we understand that these 4 bytes are related to the strength. Indeed, this is the binary representation of the number 10. And the health, 12. So these 4 bytes are for the health. So we understand that the structure has just packed all our data close together. And for some reason, we have here some padding. So it's a concept which we won't cover in this video, but the compiler, in order to optimize things, sometimes it has to add more blocks in order to have everything be, for instance, a multiple of 16 in terms of memory. Now, if you come from the Python world, you might ask yourself, okay, but how am I going to call methods on structs? Because here we have nowhere to define methods. So the way to do that, a method is going to be a function like any other. For instance, is character dead, and it takes as an input a player, and now it's going to return player.health. So the character will be dead if only if the health is less than 0. So yeah, in C, the type bool, we might have to include it, as we've seen actually in our last video. It doesn't come by default, stdbool.h. And the answer is 0. No, the character is not dead because we have 12 of f. But if we go to minus 12, yes, the character is dead. So with this example, you can see how to handle any kind of method. You're just going to pass your struct and do what you want to do on it. Note that the default behavior for almost any type in C, when you pass something to a function, is to copy the information. So here, for instance, if I wanted to say player.avatar equals sharp, here I'm going to call the function and print the avatar. We can see that the avatar has not changed, and that's because the information of player was actually copied when we passed it to the function. This means that our methods won't be able to actually change the state of the player. Let's say that you want to increase or decrease the health. With the tools that we currently have, we are not able to do this. We'll need to wait for pointers that we'll cover in a future video to actually change the state of a struct when we pass it to a function. Now we're going to talk about another concept of the C language, which are enums. So enums are a bit present in Python, although they are not developed a lot by default. And an enum is just a set of possibilities, which is very relevant when we talk about a RPG game, because you could think of the player's class. For instance, you could be a warrior, or you could be a wizard, or you could be a priest. And this will call player class. And now in our player struct, we can say player class. And now when we define our player, we can say class equals warrior. So an enum is just a convenient way to represent a concept with a label that we can later use in more complex data. So a way to use enum in practice, for instance, if we want to do a method which is can use magic, that will say if the player is allowed to use magic or not, will return can use magic player, should answer no, or 0, because our player is actually a warrior, 0. And if we had put a wizard, we'd seen a 1. In memory, enum is generally encoded as an integer. So for instance, here if we ask for size of size of myPlayer.class that answers 4, which is the size of an int. So it means that the compiler internally treats each of these values as an integer. So if we show bits, what we will see 1 here because I've taken a wizard, and if I take a priest, the compiler will assign it to 2. So you see the compiler, in fact, it maps these labels to the value 0, 1, 2. And in fact, you can set the starting point for these values. You see it's just incrementing, but if you want to start at the value 5, this should work and say that now 5, 6, 7, 1, 1, 1 is the value 7. The last concept we're going to talk about in this video is the concept of union. It's a concept which is quite specific to C. I mean, with respect to Python, it's not something which is, I think, so much developed in Python. And a union is basically a data structure that can hold only one of the possibilities that you specify. So for instance, let's say that we have the following setup where if you are a warrior, then you'll have maybe a sword power, which is the power of your sword. But if you are a wizard, you'll maybe have a favorite spell, which is a string of 10 characters. And if you are a priest, maybe you have a healing power. So you see that these values are never going to be defined each at the same time. There's only one which is going to live within each player. And here we can call it class power. So it depends on your class. And when we define this class power, here, because I have a priest, this is going to be equal to only defining healing power to 5. So if we compile this program, this works, and you can see that basically the union allows us to define data that where only one of these fields should be used. And intuitively, then you can understand that a union is going to take less memory than a struct, because in a struct you need enough memory to represent all the elements, whereas in a union, in theory, you need enough memory just to represent the maximum, the element that takes the maximum number of bytes. Here, we use 10 bytes versus 4 versus 4. So to represent what is a class power, in theory, I only need 10 bytes. Whereas if it was a struct, I would need 10 plus 4 plus 4 being 18. This becomes very important if you were doing something like embedded programming, where you need to be very aware and of the resource that you are using. And a union can save you a lot of space by specifying that only one of these fields will be defined at any time. Now, when you use a union, you should be really careful not to mix a union field. What do I mean by this? Is that here we've said, okay, class power is going to be healing power equals to 5. But if later on you come and say, no, in fact, I'm going to say that myPlayer.classPower dot, and let's say sword power equals 6. If you try to access both these values at the same time, the issue is that they are sharing the same memory. So they are going to corrupt one another. And the result of what I'm going to write is most of the time undefined. So here, if we ask what is sword power and healing power at the same time, we're reading 6, 6 instead of 5, 6. That's because in a union, all our fields are going to share the same memory. So if you start defining two fields at once, but you're going to erase or change or corrupt the data that you just had written. And you see that the compiler sends us no warning whatsoever about that in the default warning mode of GCC. Union are a great concept to save memory, especially if you work with embedded programming, but it can be also dangerous if you use it wrong. With scalar types, structs, union, enums, arrays, and strings, we have roughly covered all possible types in C, apart from a big one, which are pointers, which we'll cover in a future video. And remember later on when we introduce function, we've said that almost all types work by copy. It means that when I send player to my function is actually working with a copy of player. So if I start to change the attributes of player, the external world is not going to see it because it will stay inside the function. However, there is only one exception to this, is the array type. The only type which is not sent by copy but which is sent by reference is the array type, and that's related to the fact that it decays to a pointer, something that we'll see later. But just to get an idea of it, for instance, if I take a function f that takes an array and I start saying array0 equals 12, we're going to see that it's going actually to change the value. So here if I say then we call the function, then we call array0. Here, the compiler just told me that I said the return type was int, but I didn't return anything. So in fact, I will put that to void. Void means I do not return anything. So you see that at first, we've seen 34, which was the first value of the array. We've sent the array to the function. And if the behavior was copy, here we should read 34 too, but no, the only type which will act as if it was sent by reference are arrays, because here you see I've said array0 equals 12, and now I end up with 12 in my array. So in today's video, we've talked about more complex types and scalar types, because we've talked about arrays, strings, which are just an array of char, structs, enum, unions, which is maybe out of all these types, the types that you will maybe end up using the less, struct being the ones that you'll end up using the most. And we've talked about function. We've seen that function are not very different from Python function, except for the fact that they by default work by copy, and that the only exception to this are arrays, that when you send an array to a function, by default it will act as if it was sent by reference. And that's because it so-called decays to a pointer, which is a concept that we'll see very soon. Thank you very much for watching, and don't hesitate to comment if anything could be made clearer in this video. Thank you.